So what's this thing? Here we have a circle, center 0, 0, and the radius is 1. And do we remember the equation of this? Remember, it's x minus h all squared plus y minus k all squared equals r squared. H and k is the center, so we've just got x squared plus y squared equals r squared, and r is 1, so it's 1 squared, which is just 1. That is the equation of this circle. And this circle has a special name. It is called the unit circle. And we're just going to look at some basics of the unit circle, and because we're going to be doing sine, cosine, and tan of angles larger than 90, or sine, cos, and tan of 90, we actually need another definition, because you can't have a triangle with an angle of 0 in it, can you? So you're going to sort of forget everything you know about SOHCAHTOA and triangles just for a second. What I'm going to do here is say, let's say I have a point on the circle xy, and I'm going to draw a radius. Okay, so there's a radius, and what I'm going to do is I'm going to make a right triangle. Connect up a right triangle here, like so. This has hypotenuse 1, isn't it? Okay, because the radius of this circle is 1, and I've just drawn another radius. I'm going to call this angle here theta, right? Like what we've been doing, right? We start here and we go an angle theta. Now what I'm interested in is, what are these lengths here? So I go from here to here, I go xy, right? So to get to this point xy, I go x along, so this is x. And then I go y up, I get y. And what if I use Pythagoras here? I get x squared plus y squared equals 1 squared, which is the equation of the circle. That all works out. But what I'm going to do now is go to trigonometry here, and this is where we come up with our other definition. So what is sine theta here in this triangle? Sine theta is opposite over hypotenuse, so SOHCAHTOA. Opposite is y, hypotenuse is 1, so it's y over 1. So what we've got to remember is sine theta equals the y coordinate of this point here. That's the first thing we've got to remember. Second thing, let's do cosine. And if you want, you can pause me and work ahead, see if you can get the answer before I do. Cos theta is adjacent over hypotenuse. Adjacent is x and the hypotenuse is 1. X over 1, so cos theta is the x coordinate of this point here. And of course, you see what we're going to do next. We're going to do tan theta. What is tan theta? Tan theta is opposite over adjacent. It says y over x. And that's tan theta. So tan theta equals y over x. So what we can do is we can also think of this point as, instead of xy, you can erase that now. And you can think, well, this is cos theta sine theta. You can also think of it that way. You've got an angle theta here. The coordinates of this point here on the unit circle are going to be cos theta sine theta as you move around. And there's a couple of side things we can do here. Well, the equation of the circle is x squared plus y squared equals 1, but x is cos theta and y is sine theta. Well, that's interesting. That gives us an interesting little result here. Let's write that x squared. So we could say that cos theta squared plus sine theta squared always equals 1. No matter what theta is, this is always going to be true. And let me just demonstrate that. What's some value of theta we know? Let's just go back to degrees for a second. What if theta is 60 degrees? Okay, so what is cos 60 all squared plus sine 60 all squared? Is that 1? Let's figure it out. What's cos 60? Cos 60 is 1/2. That all gets squared. What's sine 60? That is root 3 over 2. That all gets squared. A half all squared, square the top and bottom, 1/4. Root 3 on 2 all squared, square the top and bottom. Root 3 squared is 3, 2 squared is 4, and we get 4 over 4, which is 1. Okay, so it works. Okay, so that's one interesting identity that will come up. And this gets kind of annoying using the brackets here. We actually write it like this: cos squared theta plus sine squared theta equals 1. So we put the squared between the whatever the ratio is and theta. And there's another one. Tan theta is y over x. I can also write this. Tan theta is y. What's y? Y is sine theta. Sine theta over y over x. X is cos theta. This is another interesting little result that comes up. No matter what angle you have, sine of the angle divided by cos of the angle will give you tan of whatever that angle is. For example, what about 45 degrees? Tan 45 degrees. Is that the same as sine 45 degrees over cos 45 degrees. Let's have a look. What's tan 45? Tan 45 is 1, isn't it? Oh, I can't remember. 1 root 2, 45 degrees. Just thinking back to those triangles. Opposite over adjacent, 1 over 1. Yeah, tan 45 is 1. What's sine 45? Sine 45 is 1 over root 2. Root 2 over 2. Cos 45 is also root 2 over 2. So you get something divided by itself, which is just going to be 1 equals 1. So yep, that all agrees.